Hello, thank you for joining Cure Alzheimer's Fund today for this important presentation. I am Meg Smith, CEO of our organization, and I hope you will allow me just a few minutes to introduce Cure-Alz. We were founded with one mission: to fund research that will accelerate prevention, treatment, and cure for this disease. To that end, since 2004, we have deployed more than $195 million toward extraordinary research pursued by brilliant and determined scientists. Our dedicated donors make all of this possible, people who share our drive and commitment to end this disease and its terrible impact on patients, families, and our communities. We are grateful for their trust in us, and we are determined to honor it by finding and funding the vital research that is the only way to achieve progress. Our board of directors and trustees hold us accountable to our mission. They and certain other supporters cover all of our operational overhead. This generosity and vision mean that our other wonderful donors know that 100% of their gift goes directly to our research program. At Cure-Alz, our only goal is to find solutions to help the Alzheimer's community. We do not pursue profits or financial returns. All of our scientific decisions are made by active researchers who themselves are at the forefront of discovery. Our research leadership group guides our scientific funding. They are experts in scientific specialties relevant to Alzheimer's, who lead labs at top academic research institutions around the world. They determine what investigations we will support, always ensuring we pursue the ideas that science and data tell us are the most likely to make a real difference for current and potential Alzheimer's patients. Thank you again for joining us today to hear about the science and progress that matter in Alzheimer's. We hope you will continue to join us in our mission to end this disease.
This is the title of my talk, The Puzzle of Sex, Gender, and Alzheimer's Disease. Before I begin, just to give you a very brief background. So the left side shows the country of India, and the red symbol shows the state where I'm from, which is called Tamil Nadu, and the city used to be called Madras, where Madras shirts came from. Now it's called Chennai, which is a very famous, renowned temple city. And so I migrated from there after I finished medical school, and I came over to North Carolina because of my interest in brain and healthy aging. Also very interested as an immigrant in cross-cultural studies and the interplay between genetics and lifestyle, how those two factors interplay to drive aging and health. And so it's kind of the rest of my talk relates to that interest, and that's one of the reasons why I got into the study of sex and gender differences. So the right side is Duke University and Duke's famous Duke Chapel, and the medical school you can see as one of the buildings there. And that's where I'm seated right now. So I hope the title of this slide is not blocked, but about 15 years or so ago, this particular statistic was being floated around in the United States, and it really caught my eye because I had been working in the Alzheimer's field for about 10 years at that time. And in a lot of my clinical trials, I did notice that the majority of participants tended to be women. I always knew that the majority of caregivers in the United States are women, and so it is the rest of the world. The women face a much larger burden of Alzheimer's caregiving, but I was not aware that it was this much of a difference between men and women in terms of the prevalence of Alzheimer's. Now, obviously, the first thing that you see a statistic like this, it makes you wonder, is it true? And if it is true, what could be the possible reason or reasons behind this? And is there a potentially modifiable or preventable reason that we could identify to then sort of help lower the disproportionate burden of Alzheimer's in women? So that became one of my areas of interest. I applied for funding from the Cure Alzheimer's Fund. They were very efficient, maybe the most efficient funding organization I have ever worked with in my life. And over the last 2 to 3 years, I've been working on a specific project whose results I'll share with you today. So some definitions. The definition of sex and gender has gotten a little bit more complicated in recent years. sex is typically used to refer to biological issues, biological status and biological issues. So when I talk about sex differences, I'm typically talking about biological differences. For example, differences in the rates of heart disease, or differences in the amount of plaque buildup in your blood vessels, or differences in blood pressure rates, so on and so forth. By gender, we're talking about behavioral and psychological traits. So gender is typically a socially constructed role and attributes that a society considers appropriate. But when I talk about gender differences, I use the term to talk about psychological differences or behavioral differences or lifestyle differences. For example, there are gender differences in the rates at which men and women practice yoga, or there are gender differences in health-seeking behaviors between men and women. So that's just definitionally how I'm planning to use those terms. And I'm also just using men and women in my talk. Technically, I think I read somewhere that right now there are something like 65 different gender identities. So I'm not getting into that level of nuance in my talk. I'm just going to focus on comparisons between men and women. So when we try to do research between men and women, we have to keep several potential confounding variables in our mind. So in the United States, as well as in much of the world, both the developed world and developing world, for almost like 50, 60 years now, this has been well known, women live much longer than men. They have, on average, between 5 to 8 years higher life expectancy than men. And what you're seeing on this graph is a very interesting interplay between socioeconomic status and your life expectancy. And on the horizontal axis, you're seeing sort of how well off someone is, ranging from 0, where they're very poor, to 100, where they're like in the Jeff Bezos category. And on the vertical axis, you're seeing someone's life expectancy at age 40. That is, if you're 40, at what age, if you're currently 40, what age can you expect to live to? And what you're seeing, first of all, is if you're very poor, which is at the left end of the graph, there is a marked difference between men and women in terms of life expectancy. It's almost like, something like, maybe 10 to 15 years. And likewise, if you look at men, which is the blue line, the poorest men versus the richest men, you can see there's almost a 15-year difference in life expectancy depending on your income levels. With women, that's a little bit less. So the key point here is that, yes, women live longer. So you would expect, because Alzheimer's is a disease of aging, you would expect the burden of Alzheimer's to be higher. So the first question to ask is the higher prevalence of Alzheimer's solely due to the fact that they are living longer, or is there more to it? And one of the ways to study that is to do a type of study called as an incidence study, where you prospectively examine people who are healthy and follow them over time, and you measure the rates at which people develop Alzheimer's disease. And that statistic is not confounded by what we call as this life expectancy bias. Now, the second issue to consider is, if there is a difference, is this a genetic difference, or is this a lifestyle difference, or is this due to some kind of an ascertainment bias caused by a difference in health-seeking behavior? So when we talk about chromosomes, we think of men as the sort of the stronger sex. You ask men, of course they'll tell you I'm stronger. I play all these like contact sports and so on and so forth. I can lift heavier weights. But when it comes to the genes, it's actually the opposite. The X chromosome is much, much, much bigger than the Y chromosome. The Y chromosome, I don't know, maybe has like 60 genes. It's the little guy out here. And the X chromosome has something like 1,000 genes. And studies suggest that the Y chromosome is actually getting smaller and smaller and smaller. But the point is, very little research has been done to understand the genes in the X and the Y chromosome and how they pertain to brain aging or longevity. More recently, there's been an increased array of research, and I'll share with you a little bit of that. And then lifestyle, we all know that men and women differ dramatically in multiple aspects of their lifestyle. That's why, we call them men are from Mars and women are from Venus, right? Men, do more dangerous sports, more likely to drink heavily. They're more likely to have risky behaviors, maybe less likely to visit a doctor, put off visiting doctors. Women, on the other hand, are more social. They form deeper social connections, which have been shown to reduce the risk for dementia, maybe less likely to have head injuries from risky sports, maybe less likely to have occupational hazards of toxins or pesticides or environmental issues. They're more likely to do yoga and other kinds of activities that may be helpful. So anyway, so there are some differences. And these also potentially need to be taken into account when you interpret statistics of men versus women. So there are a number of known differences between men and women in terms of risks for other kinds of diseases. So I just want to share with you some of them. For example, it's well known that men are at higher risk for stroke, heart disease, some types of cancer, hearing loss, head injuries, alcoholism. Now, we know that stroke, heart disease, alcoholism, head injury, hearing loss, all of these increase your risk for dementia. So we have to take into account some of these comorbid risks as well. And then women, their risk profile is different. Women are more likely to be diagnosed with depression, either because they truly have a greater risk or maybe more likely to want to seek help. They're more likely to have certain autoimmune diseases, more likely to have multiple sclerosis. Interestingly, adult women are more likely also to catch viral infections. And we know that infections could also potentially be a risk for some types of dementia, even possibly Alzheimer's disease. So given that background, we said, okay, so I had proposed to the Cure Alzheimer's Fund saying, right next door to you in Boston, there is a wonderful resource that's not been fully tapped to answer this particular question. I would like to get a grant from you, and I want to study this question: do women truly have a higher incidence of Alzheimer's disease? And if there are there any preventable causes that we can identify? So I turned to this particular study called the Framingham Heart Study. Those of you who live in Boston obviously know this, but those of you who don't live in Boston, Framingham's a town about 20 miles outside of Boston. And its tagline, different towns have funny taglines, but this town, a really cool tagline, it says the town that changed America's heart. And I can add to that, thanks to Cure Alzheimer's Fund, it may be the town that also changed America's heart and brain. And the Framingham Heart Study started in 1948. Very interesting. Back in the 1930s, Americans didn't really take care of their heart very well. Their dietary habits were bad. At that time, the links between high blood pressure, high cholesterol, and heart disease were not established at all. In fact, in 1938 or 39, President Roosevelt had high blood pressure, and his personal physician said, hey, it's no big deal, because nobody even knew what the limits of blood pressure were or what is the optimal blood pressure for managing your heart risk. So he was examined, he was told he was okay, and you can see his blood pressure, his systolic blood pressure kept rising, 150, 200, 250, and finally he died. It crossed like 340. And you can see his diastolic blood pressure went all the way up to like 180 or 190. So his whole blood pressure was mismanaged because no one really knew it. And after he died, the next president decided, you know what? 40% of Americans have heart disease. We don't know anything about it. It's the highest cause of death rate. Let's start a national landmark study. So they created the National Heart Institute, and they funded the Framingham Heart Study, and they recruited a large cohort of people living in the town of Framingham because it was a working class community at that time. And they said, we want to follow you for generations, to measure your blood, to measure your physical health, to measure your brain health, really to get a solid idea of what are the risk factors for common diseases. In fact, the term risk factor comes from this particular study. So I'm going to talk about one specific subset of the Framingham Heart Study called the Offspring Study. So it's not the first generation of Framingham people who were recruited in the 1940s and 50s. This is a subsequent generation of about 1,398 people with a mean age of 68 years. Roughly half were women, half were men. And these people have been followed for about 11 years. And the reason we chose this cohort, extremely well characterized, a lot of the modern laboratory techniques and assays were available, so their blood had been measured for genetic variables, for Alzheimer's related markers, for cardiovascular markers, diabetes markers, obesity markers, as well as a range of immune and inflammatory markers. And these subjects were very carefully followed annually with cognitive testing, physical exams, clinical exams, etc., to characterize their outcomes on medical conditions, as well as dementia and memory decline. So what were the overall findings? So we did see that women had a slightly greater incidence for developing Alzheimer's than men. But hidden within that overall statistic was something even more interesting, which is what I'm going to show you in the next slide. So what I'm showing you in this slide, on the vertical axis, there are 3 panels here of subjects are broken down by educational level. On the horizontal axis for each of the panels is the years of follow-up. As I mentioned, these subjects were followed up for roughly about 11 to 12 years. On the vertical axis is their risk for developing Alzheimer's disease. That is, how long did they stay free of Alzheimer's disease during the follow-up interval? The red lines are women. The blue lines are men. So if you go to panel C, which is the rightmost panel, you will see amongst people with a college or graduate degree, there is no difference at all in the rates at which Alzheimer's develop between men and women. If you go to the middle panel, which is high school and some college, you start to see a trend for a difference where women are developing Alzheimer's at a slightly faster rate than men. But there is a marked difference amongst those without high school education. And you can see women are developing Alzheimer's at a markedly faster rate, almost 100% faster rate than men. So this begs the question, is it truly a dementia that these women are developing as a result of lack of education? Is it an ascertainment bias? They're not testing as well because our cognitive tests are so biased towards people with high educational level? Or is it a combination of both? Or could it be something else? Could it be that people with low educational levels are living in bad neighborhoods where they have environmental toxins? Or could it be that people with low educational level don't have the cognitive exposures that others have that allowed their brain to be sort of engaged and to have the networks built that make them resilient to Alzheimer's? It could be a combination of all of those. So those are the kinds of questions that we need to be asking further. But this suggests that with increasing educational levels over time, as women catch up to men in terms of their education, I would expect this difference to disappear if this finding is purely due to low education related low cognitive stimulation. So that is something we can easily test in a subsequent cohort of the Framingham study, and which is one of the things we want to do. What we can also do with this kind of information is, can we develop an algorithm to identify people who may be at higher risk and maybe give them brain stimulation, cognitive training, or other kinds of gender equality remediation to try to see if we can prevent the onset of Alzheimer's. And that may be particularly appropriate given, what's one of the goals of International Women's Day. So the second question we were interested in is this only lifestyle related, or is there a genetic basis? And what this slide is looking at is the relationship between the biggest genetic risk factor for Alzheimer's, which is called ApoE, which stands for apolipoprotein E. And there's a particular variant of that called E4 that increases one's risk for Alzheimer's by anywhere from 3 to 10 times. You inherit this gene from each of your parents. If you inherit one copy, your risk goes up about 3 times. You inherit 2 copies, your risk goes up to 10 times. And some people may not inherit any copies if neither of their parents had this particular gene. But what this graph is showing is that this gene has equal effects in both men and women. In this particular study, women did not have a greater risk for Alzheimer's as a result of carrying this gene than men. So what that suggests, at least from this study, is gene therapy addressed at this particular gene is not going to change potentially sex differences in Alzheimer's disease. Subsequent to our study, there have now been a number of other genes that have been identified, including in the X chromosome and the Y chromosome, that may be related to differences in Alzheimer's risk. And that's still early work in progress, but I just wanted to let you know of that. Okay, so there are currently 2 theories of how Alzheimer's develops. The one on the left is the leading theory. It's called the amyloid hypothesis. And this theory suggests that amyloid builds up in the brain in the form of plaques and in the form of soluble amyloid. So this is a type of protein. And then these plaques and oligomers lead to the formation of tangles, which then leads to neurodegeneration of the nerve cells and the connections, which leads to Alzheimer's disease. A parallel hypothesis that is not as popular, but still has been sticking around for 40, 50 years, is that Alzheimer's comes from vascular problems in the brain. Small strokes happen in the brain that block up blood vessels, that results in lack of perfusion to the brain, that results in an energy crisis, that results in mild forgetfulness, that causes neurodegeneration. Many people, of course, have a mixture of these 2 pathologies. It depends on your risk factors. If you have a lot of vascular risk factors, such as high blood pressure, high cholesterol, you may be more likely to go down the right side pathway. If you don't have those, if you have strong genetic basis, you may be more likely to go down the left side pathway. So the question we were interested in is it more likely that women may go down one pathway and men may go down the other pathway? So we did some studies, and I'm not going to show you all of the data, but the early findings are that women may have some stronger links to the left-sided pathway with slightly greater accumulation of amyloid, greater accumulation of tangles, and a stronger relationship between their genetics and their amyloid and tangles formation. Whereas men may have a slightly greater predisposition for high blood pressure, for cardiovascular problems, and the vascular pathway for developing dementia. Now, this is still a work in progress, but if this is proven true, then what that might mean is the type of treatment you may give men versus women for preventing dementia may be different. But at this point in time, we're not there yet in terms of personalizing a sex-specific type of therapy. Now, it's also very important to know how currently approved treatments work in men and women. Many of you have heard that this drug, Leqembi or lecanemab, is the latest FDA-approved drug for slowing cognitive decline. It's an antibody that is targeted at amyloid beta in the brain, and it helps the brain to clear it. It has been approved to treat mild Alzheimer's disease or mild cognitive impairment in people who have been shown to have elevated amyloid plaques in the brain through the use of a PET scan or a spinal tap. In a clinical trial, it lowered amyloid in the brain and modestly slowed cognitive decline. Now, one of the questions that was not widely talked about when the drug first came out was, were there sex differences in how the drug improved symptoms? Recently at a conference, the company presented that when they divided the trial by men versus women, the drug worked in men, but the results were not statistically significant in women. Now, that's puzzling. You may say, okay, this is a post hoc analysis. Maybe the sample size is a little smaller, but the study had very large sample sizes, so thousands of people. So it was not like it was a 50-person study. Or maybe it's just a fluke, we don't know. The point I'm making here is that there is inadequate attention being given currently to determining whether drugs work equally well in men versus women. 20 years ago, all the clinical trials were done only in men. The NIH mandated the inclusion of women because many of the original trials, like taking aspirin to prevent heart disease, were only done in men. Now, this trial in Leqembi, actually, there were more women than men in the trial. But the fact that the drug was not significant in women is puzzling. And if it is true, that is concerning, because the drug does pose a risk for some side effects, and you don't want to expose people to side effects if the drug is not going to be effective for them. So I think it's going to be very important for us to ensure that, clinical trials, as well as journals that publish these studies, require that there is an analysis done to show that the drug works well in both men and in women. It's not just with this Leqembi. There are other lifestyle interventions. There's the MIND diet. Recently, the trial of the MIND diet failed to show benefits for preventing Alzheimer's disease. That trial did not even report whether there were differences between men and women. We recently published a trial of cognitive brain training, crossword puzzles, where we showed crossword puzzles were beneficial. And in that study, we reported that crossword puzzles benefited both men and women equally. So I think it's going to be very important as we try to put all the pieces of the puzzle together to have the data to be able to determine what is the right treatment for the right person. So I think I'm going to stop here. So in summary, there are sex differences and the incidence and prevalence of Alzheimer's. What I want to also add here is our findings in the Framingham study have now been confirmed in a very large study of Alzheimer's incidence in 45 countries and 900,000 patients that have also shown that women have a higher incidence than men. And at least 50% of that difference is due to differences in educational level. What we now need to do is to correct that gender inequality, but also see what is causing the other 50% that's missing that we don't fully understand. That's biology. Sex and gender are not taken into account yet in biomarker and drug discovery. So if we are ever to develop an AI algorithm for predicting someone's brain health, which is one of my key areas of research that I'm working towards, I want to have a set of variables I can put in. Take your age, take your clinical lab tests, blood pressure, cholesterol levels, take your family history, take your medical history, put that into an algorithm and come up with a score saying you have a 20% chance of developing Alzheimer's disease in the next 30 years. And here are the things you can do to reduce that risk. And when you do those things, whether it be meditation or going on a specific diet, you can again plug in this algorithm and the algorithm will tell you, hey, congratulations, your risk has gone down by 15%. So that's eventually what we would like to have. And so I think for these reasons, sex and gender research should be a high priority. And I really want to thank all of you for your support and hope that you will partner with the Cure Alzheimer's Fund. So I'm just going to stop here. Thank you so much.